All right, so like I did yesterday, I'm using pink for my domain and green for my range. Okay, so today we're going to find the domain and range of continuous functions. So remember, see this graph right here? This is discrete. It means I can count 1, 2, 3, 4, 5. There's 5 ordered pairs. This is a discrete graph. And we found the domain and range of these by finding the ordered pairs. And the domain is -2, and the domain is 4, and the domain is 0, and the domain is -5. So we know the domain of these, and we know the range of these ordered pairs because they're a specific spot on the graph. All right, well, today we're going to find domain and range of continuous graphs, and it's a lot different. So to me, this is the hardest thing to figure out, just because my brain is not abstract. I got to know exact. You tell me exactly what to do, I can do it. Okay, this is more abstract, which means like think of the most beautiful plant in your home and describe it. That's like really abstract. It depends on what I see, and what Grayson would see might be different. And so the abstract means it's not specific. Okay? All right, so domain. To find the domain of these graphs that are continuous, we're going to look left and right. And if you think about it, in a coordinate plane, the x-coordinate tells us on the graph which way to go, left or right. So the domain is left to right. What is the graph doing as I look to the left, and what is it doing as I look to the right? The range is what's happening to the graph as I go up and down. And essentially we're looking for boundaries, like a fence. And when my dogs are in my fenced yard, they cannot get out. They can't go outside of the fence. They can't run in the road. This is kind of what domain and range are. It's the boundaries that we're looking for. We're looking to see if there are any fences, any boundaries. All right, so in number 1, there is a boundary, but we're going to get to that in just a second. So our job is to look and see which way the graph is going, left and right. Is it starting and stopping? Is there a boundary? That's the domain. The range is which way is the graph going, up and down? Is there a boundary, a stopping point or a starting point, a fence? Okay, so the domain. I'm looking at this graph, and I'm looking, starting at the origin, and I'm going left. This arrow right here means that as I go left, what's happening to the graph? It's getting wider and wider and wider to the left. And as I go to the right, it's getting wider and wider and wider to the right. Okay, so to the left, the graph is never going to stop, and I knew that because of this arrowhead. And to the right, this graph is never going to stop. It goes to negative infinity on the left, positive infinity on the right. And when that happens, this is what the domain is. Draw those 2 lines, and we're going to make it an R. And that R stands for all real numbers. That means every decimal, every fraction, every square root, every number that exists is in the domain. It's the x values. Okay, so I looked left and I looked right. Now I have to find the range. The range are the what values? The y values. So what is this graph doing going up and down? the first thing I'm going to look at is there a boundary? Is there a starting and stopping point? And on this graph, right here, see this green line? This picture, this letter V, if you want to call it that, does it go below the green line? No. Okay, that's a boundary. It's a fence. So if my dogs are running right here, they cannot go past that green line. Okay? So as I go up, though, look what's happening here. It's going up, see, up forever, up forever. Okay, so it's continuing to positive infinity forever, but it doesn't go below that blue line. And when that happens, this is how we write the domain or range, but in this case, the range. Range is y, and this dot right here is a straight line. It's colored in, it's a point there, and all of the graph is above that number -2, and if it's above it, it's called greater than or equal to. So it's bigger than the green line, the picture is above the green line, and it's a point right there at -2. Since it's not an open circle, I use the equal to symbol. Okay, now we're going to do actually all of these examples because they're all different, but they do have some things in common, but they're all pretty much different. And our job when we are studying for our test and quiz, or doing our homework or doing any activities, our job is to take that problem that we're given and match it to one of the examples. Okay, so look at number 2. This is a continuous graph, okay, and that means that, you know, there's an infinite number of points in that circle. All right, but let's look to the left and to the right. Does this circle go to the left forever and ever? No. Does it go to the right forever and ever? No, it actually has a boundary or a fence. So look right here. That's where it starts or stops. If my dog were running, and that's an electric fence, he'd be zapped if he goes past that invisible line. And he'd be zapped if he passed this invisible line. And that would really hurt him because he doesn't have any hair. Okay? And all of the domain, all of the x's are in between those two lines. All of the x's. And what to me what's confusing is that this is an x. What I mean is all of these numbers, all of these dots represent the domain. Okay? This is what I call an in-betweener. In-betweener. And my R is going to run off. I call it an in-betweener. No one else will call it that. But this is an in-betweener. And what that means is that, watch where I'm writing my X. The domain is in between these two fences. And this fence, what's the X value of that?
3.
Negative 1, 2, 3. Left 3. And this fence is at positive 3. Okay, this is what an in-betweener domain looks like. Okay, and what that's saying is this picture, this circle is in between these 2 points. Why do I have an equal to symbol? Because when this circle passes through 3 or negative 3, there is no circle there. That means it's colored in. It means that 3 and negative 3 are part of the solution. They're part of the domain. Okay, now let's look at my y values. Does this graph go below this line right here? Nope. So there's the fence. And the boundary is up here. There's a fence. So the range, the y values, all of these numbers in between the green lines are part of the range. So it's also an in-betweener. And an in-betweener looks just like this, but since it's the range, we're going to use the letter Y. So in a multiple choice question, if the question is asking what is the domain, they're usually going to have answers that say y equals. That's not domain. The x coordinate is the domain. The y coordinate is the range. So be on the lookout for that. Now, what is my boundaries? My lower boundary is -3. And my upper boundary is +3. So that means the range is all the numbers in between -3 and +3. All right, now number 3 is different. It's a straight line, right? Okay, let's find out what is this graph doing going to the left and going to the right, the domain. So as I'm going to the left, see that arrowhead? It means it's going on and on and on forever and ever, wider and wider to -infinity. And as I go to the right, this graph is going on and on, wider and wider and righter and righter. That's not a word, but to the right, to the right, to the right, to the right, to +infinity. So when the graph never ends on the left and never ends on the right, our domain is all real numbers. Every number in the whole wide world is an answer. Okay, so I like lines. Okay, lines are the easiest ones to write the answer to, but not all lines are the same. Okay, let's check out the range. What's happening as this graph goes up and up and up? It's going upper and upper and upper and upper as it goes wider. And as it goes down and down and down, it's going to infinity. So the range is also all real numbers. Number 4 looks like number 1. Wait, does it? Okay, what's the difference between number 1 and number 4? Okay, 4 is curved. This isn't. Okay, what else? This one's going down, right? See, it's pointing down. This one's pointing up. Okay, but they're similar. So that means, hey, I'm a little confused. I'm not quite sure yet, but I know my answers might look like this or very close to it. Okay, so let's see. As this graph is going to the right, to the left, -infinity, what's happening? It's going on and on and on to the left, to the left, to the left. And this one's going to the right forever and ever. So the domain, as it gets left and right, goes on forever. It's all real numbers. But look at the range. Is the range, the y's, what's happening as it goes up and up? Does it ever stop?
Yes.
Yes, look, see this right here? There's a boundary, a fence. This graph, see this U shape? It does not go above that green line. Is the picture above the green line? No. Is it below the green line?
Yes.
Yep. Does it go down forever and ever?
Mm-hmm.
Yeah. All right, so now the range is probably going to look like this. So I'm writing down my y. What's this number right here? 1, 2, 3, 4, 5. But now is the graph greater than the line or less than the line? Less than or equal to the line. Okay, so check out number 5. So, hey, I know this one looks familiar, doesn't it?
It looks like a circle.
It looks like number 2. It's going to be an in-betweener. Okay, so hey, number 2, I drew the pink line. So let me draw my boundaries, my fence. Pink line, pink line. Okay, and notice how I'm just copying. Okay, yep. Now, I'm going to put my dot there. What's that number that I just put?
-1.
-1. All right. That goes first. It's an in-betweener. Looks like this. And what's this dot? 1, 2, 3, 4, 5. It's in between. Okay, so I just copied what it looked like in number 2. Is the range an in-betweener?
Yeah.
All right, so what does that mean? It means there's a fence or boundary right there. There's a boundary right here. Okay, and all of the y values are in between. Okay, in betweener range is y. This is what in between looks like. Now I need my dots. What's the little dot?
-3.
What's the top dot? What's the top
3.
fence, the top boundary? 3. Okay, now in number 6, you're going to see these a lot. This looks like a fun roller coaster. Look, steep hill goes up and down. That was like a fake drop right there. Okay, but let's check and see the end behavior. What is this graph doing on the left end? Well, it's going left and left and left to infinity. Is it going down to infinity? See, is it going forever and ever, ever down? Yeah. How about going up and right? Going up and right forever and down? So don't let these little things confuse you. Okay, this right here is just a bump and a bump, but the graph goes above it, and the graph goes above that, and it goes below that and below that. So there's no fence there. Okay, so anybody know the domain? If it goes on forever to the left and on forever to the right? Yep, I heard it, all real numbers. What is the range if it goes up forever and down forever? All real numbers. Okay, now number 7. This would be fun. I would love a roller coaster like this. Not too steep, but lots of hills. Okay, so check out my end behavior. How is this graph behaving or looking on the ends? What's it doing? Is it going up forever? No. But is it going to the left forever? So if this pattern were to continue, all right, see how it's continuing, even though I'm a bad drawer? And it's continuing. All right, it's going to go left forever, and it's going to go right forever. So what is the domain? All reals, good job. Is there a boundary going up and down?
Mm-hmm.
Yep, right here, look. Does the graph, the roller coaster, go below that boundary?
Mm-hmm.
Nope. Does it go above this boundary? Nope. All right. Guess what it's called? In-betweener. Good job. So that means the y is in between. Why do I put the equal marks? Because there is no open circle. If there's an open circle, no equal marks. All right, what's my smallest value? That dot right there, -3. What's my upper boundary? Right there, at positive 2. All right, now we've done one like number 8, sort of. What does it look like, kind of? So it kind of looks like number 4, kind of. See, look, if I turned it like that, it would kind of be the same, right? Okay, so let me just take a snapshot of the answers. All right, I know all reals, and my answers, one of them is going to look like that, okay? So now let me go to number 8 and see if I can kind of matchy it. All right, so looking to the left and the right. So look, I'm going left and right. Is there a fence or a boundary?
Yes.
Yes. It means where is the graph stopping or starting, and it doesn't go past that line right there. Okay, so there's my boundary. Look, right there. Boom. Okay, is this an in-between? No, there's only one fence. Okay, what is domain again? What letter? X. Okay, and what's that number? -1. Now I got to figure out which direction is it going. Is the graph to the left for less than, or bigger than, greater than to the right? All right, and we're going to put an equal to symbol because there is no open circle. Okay, now let's check going up and down, up and down. Okay, does this graph go up forever? Up, 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 and I'm off my paper going up in the air to infinity, and I'm going to hit the wall over there. It's going up forever. See this arrow? It tells me it's going down forever. Okay. So, all real numbers, I heard you. Hey, now I have a question, and I'm wondering if anybody else is thinking this. How come this right here, see, I highlighted that in pink, but how come it looks like it's going up forever, but what happens is it's hitting the fence and it's ricocheting off and going back down? Okay, so the reason why this isn't going up forever is because the pattern is continuing. Okay, and it's hitting that boundary, that fence, and that's why this answer looks like this, and this one is all reals. All right, now number 9 is a straight line. It's a trick question, though. Okay, so let's check the graph going to the left. Is this picture going to the left forever? No. Is it going to the right forever? No. But here's where it's shooting through. What number is that? Positive what? 2. Okay. So in this one, when it's a vertical line, everywhere we go, every ordered pair is going to have the x coordinate be 2. So look, this right here is 2, 2. And this down here is 2, -5. And this right there is 2, -2. And this is 2, 0. So notice all of the x coordinates are 2. All of the x coordinates equal 2. They all are 2. Now what's the range? What is this graph doing as we go up and down? Is it starting and stopping anywhere? Nope, and you're right, it's all real numbers. All real numbers. Okay, now number 10 is just a straight line as well, but is it going in the same direction? Okay, what's happening as this graph goes to the left? Infinite, negative infinity. How about as it goes to the right? Positive infinity. All right, so what is the domain? All reals. Okay, this kind of is like the one before it. Everywhere on this line, it has a y value of what number? -4. So look, this ordered pair is 3, -4. And this ordered pair is 0, -4. And this 1, 2, 3, 4, 5, 6, this ordered pair is -6, -4. Okay, so no matter where I go on this line, the y-coordinate's going to be -4. All right, now the last ones. Number 11. These are different. What's the difference between this one and, let's say, number 8 or number 7 or number 9 or 10? Anybody notice the difference? There's 2 stopping points on the left and the right. What do you notice about the stopping points? The circles. Open circle, closed circle in the domain. Okay? Stopping point. Stopping point. Ooh, what kind of X's domain is this? Look how I colored it. This is called a in-betweener. The X values are in between. All right, but here's the difference. See this equal to symbol? I put it because it's a closed circle on -2.
And the other one would be open.
The other one is open, yes. So remember, no line. And what number is that? +5. So why no line there? Open circle. All right, now let's check out going up and down. Does this graph go up forever? Yes or no? No, look, stopping point, boundary right there. Is there a boundary going down? All right, now, hey, how come I'm not picking this one, but I am picking this one? It's the lowest one. So we're looking for the tallest, the highest peak, and the lowest. Okay? If we're looking left to right, the one that's most left and the one that's most right. All right, so is this an in-betweener? Is the range an in-betweener? Yep, all right. Oh, I got to check. Is this a, hold on, bottom. -2, is that an open circle or closed circle? Open, so no equal symbol. +1, does it have a circle?
Yes.
Look right here. Is there a circle right there? No, that means I do have an equal to symbol. Okay, that means it is going through 1, it's touching 1. All right, number 12. Number 12. Look at the left and look at the right. Okay, left. How far can I go on the left? Right to there. There's my boundary. All right, go to the right. Oh, it stops right there. What's this called? In-betweener. All right, hey, closed circle, love it. -1, 2, 3, 4 is my leftist point. What's my most rightest point? 1, 2, 3, 4, 5. So that means that all of the domain, all of the X values are in between -4 and 5. Okay, let's find the tallest point. Okay, so as I go up and up and up, is there a stopping point?
Yes.
Right there. That's the maximum. Okay, the highest point, the maximum point. And wait, here's the lowest point, the minimum. All right, guess what? It's an in-betweener. Okay, why do I have equal to symbols? Closed circle right there at -3. colored in closed circle right there at 5. Okay, almost done. Okay, the next two are a little different. All right, so number 13. All right, going to the left. What's this graph doing going to the left? So right here, left, 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 left. It's going forever, right? Correct? All right, what about going to the right? Does it stop?
Yeah.
Look right there. It does not go past that. My dog, if that's my fence, cannot run in the street. Can my dog touch the fence? No. Okay. Anybody ever touched an electric fence? Woo, that hurts. Okay. Cows touch it once and then they learn not to touch it again. Okay. So we can't touch it. All right. Let's see. Did we ever have one that was like going one direction but had one boundary? Yeah, it kind of looks like number 8. Okay, so I know I have my X. What's my boundary? 2. And which direction are the X's going? To the left, less than, or to the right, greater than? Is the graph on the left? Yep, less than 2. Do I need an equal to symbol? No. Why not? Open circle. Open circle. All right, now let's check up and down. So I start at the origin. Is this graph going up forever? Or is there a boundary? No, there's a boundary. Look, does this graph, this arrow, go past the green line? Nope. Does it go down forever? Yep. All right, so I know it's going to look like the domain, except what letter do we use for range? Y. Okie doke. And it's going down forever at 0. Starting at 0, going below 0. Would that be less than or greater than? Less than. Will I have an equal to symbol? Nope, no equal to symbol, open circle. Okay, and believe it or not, number 14 looks like, I think, number 6. Yep, sure does. The only difference is, look how this has a flat part. Okay, it's going to look like number 6. So see if you can find the domain of this. What is the domain? Go back and look at number 6. All right, and is the domain going to be the same thing? Is it going to be all real numbers? So let's check. See this right there? Does the graph go past that number right there? No, there's a fence. Okay. Does the graph go past this point right there?
Yes.
Yes. All right. So actually, it's going to look like this. Oh, what is that number right there? -2. -2. Open circle or closed circle? All right, equal to. Is the graph bigger than -2 or lefter less than -2? Bigger. All right, let's check out the graph going up and down. So as I start at the origin, is it going up and up and up and up and up and up forever and ever? Yes, all right. How about is it going down and down and down? Oh, wait, hit the fence. Zzz, I got zapped. Okay, I can't go below that line. So I know my answer is going to look like this. Take a second and write what you think the answer is going to be. So Y, closed circle at -4. Did you get that answer?